So let us talk about antianginal drugs. This part we have covered during our lecture. Angina pectoris is a disease marked by brief or sudden attacks of chest pain or discomfort caused by deficient oxygenation of the heart muscles. There are various types of angina. We have discussed this part during our lecture, that's stable angina, Prinzmetal's or variant angina, also called as unstable angina, microvascular angina. We have also studied classification for angina pectoris, drugs used for the treatment of angina pectoris. In that, nitrates are the major category which is useful for treatment as well as prevention. And major drugs in this class are nitroglycerin, isosorbate, dinitrate. And again some other nitrates, mononitrate is over, isosorbate, mononitrate, isosorbate, dinitrate, glycerol, trinitrate, erythritol, tetranitrate, pentaerythritol, tetranitrate. So this part is also easy to remember: mono, di, tri, tetra and penta. Some easy words are there so that we can correlate and memorize that. In case of beta blockers, we have example propranolol, metoprolol, atenolol. And you all know propranolol is a non-selective beta blocker, while metoprolol and atenolol have the para position substituent, and that indicates they are the beta 1 blockers, aromatic ring with para substituent. Then potassium channel opener, we have example nicorandil. And in case of miscellaneous, we have example oxyphedrine, dipyridamole, trimetazidine, ranelazine. We have also studied calcium channel blockers, that is also called as CCBs. In that, we have example phenylalkylamine derivatives. Example is verapamil. Benzothiazepine derivatives. Example is diltiazem. And dihydropyridines examples are nifedipine, felodipine, nicardipine, nitrendipine, benidipine, lacidipine. Moving towards next slide, we have nitrates. So classification of nitrates: rapidly acting and long acting nitrates. We have also studied mechanism for nitrates, that how they are responsible for vascular smooth muscle relaxation. Organic nitrates, in that I told you to remember guanylate cyclase enzyme name, which is important. We have also studied during our previous lecture, amyl nitrate possesses 5 carbons included in it and CH3 at the second position, that is iso position. So amyl nitrate is a mixture of isomeric nitrate. It may be prepared from amyl alcohol. So starting material for amyl nitrate is amyl alcohol. Amyl nitrate is a yellowish liquid with ethereal odor or pungent taste. It is volatile in nature and flammable at room temperature. Nitroglycerin is a derivative of glycerol. Glycerol means you know structure CH2, OH, CH, OH and CH2OH. So that H from all three positions is replaced by NO2, NO2 and NO2. So easy structure, this is a glyceryl trinitrate. We have also studied this mechanism of action, pharmacokinetics, and structure for isosorbate dinitrate, isosorbate mononitrate. There is a minimum difference of NO3. NO3 at 2 positions is observed in case of isosorbate dinitrate, while NO3 is at only 1 position. And isosorbate dinitrate is a major category, and its metabolite is isosorbate mononitrate. Means if it is asked in examination which is the metabolite of isosorbate dinitrate, you will tell that Isosorbide mononitrate is the active metabolite of isosorbide dinitrate. Means which one is the active form? Isosorbide mononitrate. And which one is inactive form? Isosorbide dinitrate. When absorbed orally, it undergoes first pass metabolism. Bioavailability is high. Its T-half is given here so that long acting it is proved. Adverse effects of nitrates are common for all nitrates, that is thrombin headache, flushing or redness of the face, dizziness, postural hypotension and rashes are rare. Now moving towards actual lecture today, this was revision. आवाज येतोय का? Yes, am I audible? Beta blockers. In that we have example propranolol. So you will draw two aromatic rings and oxygen bridge, then 2-propanol and then isopropyl amine. IUPAC name for propranolol is 1-isopropyl amino. Numbering is given here 1, 2, 3. So 1-isopropyl amino, 3, 1-naphthyl oxy propane 2-ol. Uses of propranolol are treatment of supraventricular arrhythmias, which include arterial flutter, paroxysmal supraventricular arrhythmias, and arterial fibrillation. Metoprolol also belongs to beta-1 blocker. In that we have example that aromatic ring, oxygen bridge is common, 2-propanol is there, and isopropyl amine is there. At the para position, CH2, CH2O, CH3 is attached. So Me, that is methoxy, and E, that is ethyl. In that way you can remember this methoxy group and CH2, CH2 means ethyl group. So IUPAC name is given, numbering is given as 1, 2, 3. So at the first position there is isopropyl amino. At the third position and to that fourth position there is a 2-methoxy ethyl phenoxy group. And parent we can consider propane 2-ol. Mechanism of action of metoprolol is it is a selective beta-1 receptor. Beta blocker binds with receptors of epinephrine. They bind to stress hormone, reduce their effect. Side effects of metoprolol are hypotension, fatigue, diarrhea, bradycardia, insomnia. Uses of metoprolol are treatment of cardiac arrhythmia, glaucoma, atrial fibrillation, hypertension and anxiety. Atenolol, we have structure aromatic ring where there is oxygen bridge, 2-propanol and isopropylamine. At the para position there is CH2CONH2, that means acetamide, and IUPAC name for the same is RS2,4,2-hydroxy. As there is a second position hydroxyl group is there, therefore 2-hydroxy, 3-propane 2-il amino, propoxy, phenylacetamide. Mechanism of action of atenolol. Atenolol is a type of selective beta-1 antagonist. Beta blocker is a class of drugs used in treatment of cardiovascular diseases and hypertension. Beta blockers act as inhibitor which stimulates hormones on beta adrenergic receptors in nervous system. Side effects of atenolol, very common they are, easy to remember: dizziness, headache, constipation, diarrhea, etc. Atenolol provides weaker protection action against cardiovascular complications. myocardial infarction and stroke. Uses of atenolol are treatment of angina, acute myocardial infarction and hypertension. This is scheme of synthesis for atenolol, where there is a starting material is epichlorohydrin, 4-hydroxyphenylacetamide and isopropylamine. If we observe our target molecule carefully, upon disconnection at two sides, we can easily get three starting materials or synthons, and making them stable, we get synthetic equivalents for the same. Now moving towards next part, calcium channel blockers. Calcium channel blockers, we have example verapamil. In this IUPAC name, observe that at the 5 position there is a 3,4-dimethoxy phenylethyl group and methyl amino 2. At the second position there is a 3,4-dimethoxyphenyl, and again at the second position we can see it is isopropyl group, and parent is taken as valeronitride. Mechanism of action of verapamil. It was introduced as a coronary vasodilator and is prototype of Ca2 plus channel antagonist. Verapamil majorly acts on slow Ca2 plus channels. Where it acts on slow calcium channels. It is a coronary vasodilator. The result is slowing of AV conduction and sinus rate. Verapamil is a synthetic compound possessing a slight structural similarity to papaverine. This might be asked in MCQ, that which is the structure having similarity with papaverine. So you can easily tell answer for that is verapamil. It was separated into its optically active isomer, which is levorotatory. It is rapidly absorbed after oral administration. T-half of the verapamil is 5 hours. Side effects of verapamil, again nausea, dizziness, fatigue, constipation, these are the common side effects, and increased urination. Now in case of uses of verapamil, we have example malaria, diabetes, angina pectoris, vasospasm. As we are studying angina pectoris, it is easy to memorize that its use is angina pectoris, or in the treatment of angina pectoris. Now moving towards next part, we have example nicaradipine. Nicaradipine is a structure where there is a 1,4-dihydropyridine. At the second and sixth position there is a methyl group. At third and fifth position, that is occupied by ester functional group COOR. At the fifth position there is a methyl group, while to this side we can observe that ethyl, nitrogen attached to methyl, and benzyl group. Means, you can remember that in three parts, that is ethyl, methyl amino and benzyl. Ethyl, methyl amino and benzyl. At the fourth position there is a metanitrophenyl group. So IUPAC name for the same is 2-benzyl methyl amino ethyl methyl 2,6-dimethyl 4,3-nitrophenyl 1,4-dihydropyridine 3,5-dicarboxylate. So here our parent is 1,4-dihydropyridine 3,5-dicarboxylate. Moving towards next part, mechanism of action for nicaradipine. It is a potent vasodilator, systemic, coronary, cerebral and renal vasculature. It is also used in the management of stable angina. We already studied types of angina in that first part, that was stable angina. Side effects of nicaradipine are dizziness and low BP. Uses of nicaradipine, you can tell it is used in the treatment of angina pectoris. It is also used as an antihypertensive agent, because you know that 1,4-dihydropyridine derivatives are antihypertensive agents also. Now moving towards next structure, it is nitrendipine, where you can draw 1,4-dihydropyridine. Then at this second and sixth position should be occupied by